All right, so we have the zero product property. Now this states that if A times B equals 0, then either A or B is equal to 0. So if A or B is 0, then when we multiply those two numbers together, we'll get 0. So we can apply it to an example like this, where if this factor, x plus 2, somehow equals 0, so if we found a value of x that made this 0, then this will be a true statement. Likewise, if we found a value for this factor that of x that made this 0, then some number times 0 will equal 0. So let's take a look at an example to work on. So this example is literally this problem. So the way we go about solving this is that we have these two factors, x plus 2 and x minus 5 equals 0. So because it equals 0, this makes it the zero product property. So the way we go about solving this is we set this factor equal to 0. Then we want to solve it. So we have x plus 2 equals 0. So we subtract 2 from both sides. We're left with x equals negative 2. We can do the same thing for this number. Our factor x minus 5 equals 0. Get x by itself, so add 5 to both sides. We get x equals 5. And what happens is that when we plug in negative 2 up in here, we get negative 2 plus 2, which is 0. So we end up getting 0 times this number. Likewise, if we plug in 5 for x here, we get 5 minus 5, which is 0. So we get 0 times whatever this is, and that makes it a true statement. So our final answer would be x equals negative 2 and x equals 5. So we'll take a look at a second example. We have 3 examples for this. So we want to do the same thing. We have this factor times this factor over here equals 0. So we set this factor equal to 0. So we have 8t minus 7 equals 0. We want to get 8t by itself, so we can add 7 to both sides. We get 8t equals 7. Now we want to get t by itself. This is 8 times t, so we need to do the opposite operation of times, which is division. That will undo it, so we divide both sides by 8. We're left with t equals 7 over 8. That means when we plug in 7/8 up here for t, we'll get 7 minus 7, and that equals 0. So 0 times something equals 0. So let's solve for t in this factor. We have 3t plus 5 equals 0. We want to get 3t by itself, so let's subtract 5 from both sides. So we're left with 3t equals negative 5. Now we want to undo this right here because we want to get t by itself. This is 3 times t. We need to divide by 3 to undo it. So we have t equals negative 5 over 3. This means when I plug in negative 5 over 3 into this right here, we end up getting negative 5 plus 5, and that equals 0, which then makes this true. So we'll do one more example of these problems. So again, we have two factors. It may not be obvious, but it's like we have parentheses here. This is 3m times 2m plus 9 equals 0. So this is a factor, this is a factor. So we set this equal to 0. We want to get m by itself, so we need to undo this multiplication. We can divide. We're left with m equals 0. 0 divided by 3 is 0. So when I plug in 0 for m right here, it becomes 3 times 0, which this whole thing becomes 0. So 0 times this number equals 0. So that's a true statement. Let's solve this. 2m plus 9 equals 0. We want to get 2m by itself, subtract 9 from both sides. We're left with 2m equals negative 9. We want to undo this multiplication. We undo multiplication by division. Divide both sides by 2. We have m equals negative 9 over 2. Again, when we plug in negative 9 over 2 into this m right here, we will end up with negative 9 plus 9, and that just equals 0. So our answer is m equals 0 and m equals negative 9 over 2. So now we are getting into factoring. So to solve these problems, because we want to solve by factoring, first we need to factor and utilize the zero product property. Then we'll find the values of the variables. So here we have z squared minus 10z plus 24 equals 0. So we need to solve this by factoring. So we need to kind of work backwards. You might have seen foiling where you have x plus 1, x plus 2, and foiling is multiply this and that and this and that. And then you get x squared plus 3x plus 2. Well, what we're doing is we're going backwards. We're starting with this right here, this z squared expression, and we're going backwards, and we want to make it look like this in the factors. Once we get those factors, we're going to set it equal to 0, because that's what we have. We can set it equal to 0, and then use the zero product property to solve for each value of x, or in this case, z. That'll make each factor 0. So first, we want to undo this right here. So we're working backwards. So we need to get an idea of how to factor. We can use that X chart. I don't know what the name is, but we can use this. And the number that goes up here is this one right here. We have a positive 24. The number that goes in the bottom is this one right here, negative 10. And what we want to do is we're looking for factors of 24 that will add up to negative 10. Now this looks a little strange at first because this is positive and this is negative. So what we need to look out for is this is one of those cases where our factors are going to be both negative, or those numbers that we're finding, they're going to be negative because we need two negatives. When we multiply two negatives, they need to be positive. But when we add them together, they're going to be negative. So let's just start off by finding factors of 24. Starting off with 1, we have 1 times 24. We can check for 2. We have 2 times 12. 3 times 8. 4 times 6. and then it starts to repeat itself, and we can stop once it starts repeating itself. So we're looking at factors of 24 that will add up to -10. So we know that they're both going to be negative, so we can do this because when we add them together, they'll be negative, but when we multiply these two, they'll become positive. Negative times a negative is a positive. So we're looking for two factors that add up to -10. So this adds up to -25, -14, -11, -10. So our two factors are going to be -4 and -6. So we can go ahead and plug those in. Make our factors right here. We have z minus 4 times z minus 6. Now that we have factored, we can solve using the zero property. So now we're going to work on solving it. Set this equal to 0. Z minus 4 equals 0. Solve. So we get z equals 4. Same thing here. Z minus 6 equals 0. Add 6. Z equals 6. So when we plug in 4 for z and 6 for z, that'll make this equal to 0. So let's do the same thing for this next problem. The difference here is that we have a different coefficient in front of the leading term. The leading term is going to be this term out front with the highest power of x, or the highest variable power. So when we arrange it in descending order, so this is x squared, x, no x. When we arrange it in this order, the leading term is this guy. And then this number portion is called the coefficient. So the difference is this coefficient is 8. We're used to not having any coefficients there. So we're going to solve this one a little differently. I'm going to show you a little shortcut that takes all the thinking out of it. So let's go ahead. I'm going to do some side work over here. What we want to do is, for this shortcut, when we have a coefficient out here in the front, is we take this number and we multiply it by this number. And we'll rewrite it. So we get x squared plus 10x plus 8 times 3 is 24. Now we're just going to work on factoring. So let's factor this new expression. We can work up here. So we have 24, positive 24, a positive 10, and factors of 24 that add up to 10. So we have 1, 24, 2 and 12, 3 and 8, 4 and 6. So we can see here 4 and 6 add up to 10. Those will be our two factors. So we get x plus 4, x plus 6. Now that we've done that part, we want to put this 8 back into in front of these x's. So we get 8x plus 4, 8x plus 6. Now at this stage, we want to kind of factor out any common numbers in here, because that's just part of this weird trick. So we want to factor out these numbers if we can. So we can see here that we can factor out a 4 out of this 8x and 4. So we get 2x plus 1. We want to factor out anything in here if we can. We can factor out a 2. So we're left with 4x plus 3. Now, what we're looking for to make sure we did this correctly is the factors that we were able to kind of pull out right here. They need to multiply to equal our original number. So 4 times 2 is 8, which that is our original number over here. So that means we factored out nicely, and I don't care about those anymore. I care about this. This is our brainless factoring method. So we just factored this expression right here, and we get 2x plus 1 times 4x plus 3. So we'll go ahead and bring that over here, and feel free to replay this part of the video if to make sure you get these steps right. All right. So again, now that we have these two factors, these two quantities being multiplied together, it equals 0. We can use the zero property, or the zero product property. So we set this equal to 0. 2x plus 1 equals 0. We want to get 2x by itself, so we need to subtract 1 from both sides. 2x equals negative 1. Now we need to undo this. This is 2 times x, so we need to divide by 2. So we get x equals negative 1/2. Good. Now we go up to this one. 4x plus 3 equals 0. Get 4x by itself, so we subtract 3 from both sides. 4x equals negative 3. Now we need to get x by itself, so we need to undo this by dividing. So we get x equals negative 3 over 4. So when we plug in negative 1/2 for x in this first factor, this will become 0 times something. So this be a true statement. This 0 equals 0. When we plug in negative 3/4 for x here, this becomes 0. So we have 0 times some number equals 0, and that is a true statement. So our answer for this one is negative 1/2 and negative 3/4. And we have one more for this type of problem. So we can use yellow. So we have s squared plus 12s equals negative 32. Now what's different about this one is that this isn't equal to 0. In order to use a zero product property, this side has to equal 0. So we can arrange that. If I add 32, that will undo this. We add 32 to both sides. This will become 0. So we get s, I'll move it over here, s squared plus 12s plus 32 equals 0. So now we can use the zero product property because that equals 0. But first we need to factor. So we need factors of positive 32 that add up to positive 12. So factors of 32, we have 1 and 32, 2 and 16, 3 doesn't work, 4 and 8, 5 doesn't work, 6 doesn't work, 7 doesn't work. So that's it. We have 1, 32, 2 and 16, 4 and 8. So we're looking for two factors that add up to 12. So that's 33, 18, 12. We found them. We have 4 and 8. So we can go ahead and write our factors. We have s plus 4, s plus 8 equals 0. Let's go ahead and use the zero product property, and we want to find the value of s that makes this factor 0. So we can say s plus 4 equals 0. Subtract 4 from both sides. S equals negative 4. Same thing over here. find the value of s that makes this 0. We can do that by setting it up this way. S plus 8 equals 0. Subtract 8 from both sides. S equals negative 8. So we have our answers here. S equals negative 4 and negative 8. Just kidding, we have two more. Two more of these. So this one looks a little different. We don't have any constants, but the concept is still the same. In order to use the zero product property, we need one side to be 0. So you might think, oh, if I divide both sides, that leaves us with a mess. Let's just subtract 5d from both sides. So when we do that, if we subtract 5d, that becomes 0. And then we'll subtract 5d from this side. We'll write it over here. We have d squared minus 5d equals 0. So let's see, we need to factor this out. We want to find a common value between these two if we can. We notice this is d squared minus 5d. They have a d in common, so we can factor a d out. So we have d times d here minus 5 equals 0. So we can use since we factored, we can now use the zero product property. Set this factor equal to 0. Surprise, d equals 0. That's it for that one. And then we can do d minus 5 equals 0. Add 5. We have d equals positive 5. So for this one, our solution is d equals 0 and d equals 5. And for this last one, we have a coefficient in the front here, and it's not equal to 0. So we need to move this negative 12 over and get this side equal to 0. Then we'll use our special factoring rule that we learned a few problems ago. So let's start by adding 12 to both sides. We get 3j squared minus 20j plus 12 equals 0. All right, so a quick reminder of our rule that we did. Since we have this coefficient in front, it makes our factoring a bit more difficult. So this method just makes it much easier where you don't have to think about it. You just remember the steps involved. So we take that number in front and we multiply it by that number. So let's rewrite it up here. We get j squared minus 20j plus 3 times 12 is 36 equals, we don't need to solve it. We just want to factor it. So now we can go about factoring this as usual. We'll make our little x up here to help us out. We want factors of a positive 36 that add up to negative 20. So when we multiply these two numbers, they need to be positive. And because that's negative, that means our factors will be negative. Two negatives multiplied together give us a positive. So that should be really easy. We don't have to do anything special. And if you remember our little chart, this is a negative then a positive. So when it's negative then a positive, that tells me right away that these two factors they'll be both negatives. In this case, we can see that in this example. So factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And then it starts repeating itself. So they need to add up to 20. We have 37, 20. That was easy. Negative 12, sorry, negative 2 and negative 18. So we can go ahead and put those in there. We have negative 2 and negative 18. Now, at this point, remember, we got to take this number again, this 3, and plug it back in front of each variable. So we get 3j minus 2, 3j minus 18, and we look at each factor to see if we can factor anything out. So this is 3j minus 2. We don't have anything that can factor out nicely, so we leave it. We have 3j minus 18. Well, we can factor out a 3 in this case. So factoring out a 3, we get j minus 6. Now when we're done taking out all of those numbers, we look to see what's left over. If this number is the same as this, then we're all done. So we factor out of 3, and that was the original number we put in there. So we are done extracting those numbers. So we're left with j minus 6 and 3j minus 2 as our two factors for this. We have 3j minus 2j minus 6 equals 0. Now we can use the zero product property. So we set this equal to 0. 3j minus 2 equals 0. Add 2. We have 3j equals 2. We want to get j by itself, so let's divide by 3 and scoot it over here. So we get j equals 2/3. We'll move this one over just a little bit. We have j minus 6 equals 0. Add 6 to both sides. J equals 6. So our solution to this problem is j equals 2/3 and j equals 6. Okay, so for this next section, we want to use the zero product property to solve each equation, then to write our solutions as a set in roster form. So roster form means that all the elements of the set or your answers are included in these brackets and are separated by commas. So if I figured out that, I solved and said x equals 5 and x equals 6. Now, in a made-up problem. Well, to put it in roster form, I would do a curly brace. I'd say 5, comma, 6 to separate each answer, and then I'd close it off with that. So that's how I would express the answer. So in this case, we will solve for k. So we're going to need to factor again, then use the zero product property to help us solve it. So more factoring. We have k squared minus 11k plus 30 equals 0. We can set up a little factoring x. We need factors of positive 30 that add up to negative 11. So because it goes negative then a positive, then I know right away that I'm going to have a negative and a negative, because when I multiply two negatives together, I'll get a positive. So we can go ahead and find factors of 30. 1 and 30, 2 and 15, 3 and 5, 3 and 10, and 5 and 6. So these are all going to have the same signs. They're all going to be negative, so we can just add them together to see which one equals 11, or in this case, negative 11. We can see right away 5 and 6. So our two factors are negative 5, negative 6. We get k minus 5 and k minus 6 equal 0. Oh, surprise. The numbers I chose are actually the actual answers for this. So we use the zero product property. We set this equal to 0. K minus 5 equals 0. We want to solve for k, so we add 5. K equals 5. And then we can do the same thing to this. Add 6. To undo it, we have k equals 6. So we have k equals 5, k equals 6. They're not happy with this form. They want it in roster form. So the way we will express that will be, we have those curly, that's good enough. Nah. This curly brace, we have 5, 6. You get the point. So we have 5 and 6. So this is how they want the answer. We'll do one more example. Same thing. We want to factor, then use the zero product property. So let's factor this. We have a -7 goes up top, and -6 goes on the bottom. So we want two factors of 7 that add up to -6. And we see that it goes negative, negative. So we're going to have different signs. So we have 1 and 7. And if it helps, we can do it this way, where we know one of them will have to be negative. We can say -1 times 7 or 1 times -7. So we want to find the one that adds up to a +6. That's -6. That is a +6. This one's a -6. So that's what we're looking for. We want this one. So we have 1 and -7 for our factors. So we can go ahead, set this up. X plus 1, x minus 7 equals 0. Use the zero product property. X plus 1 equals 0. Get it by itself. X equals -1. Same thing for this factor. And for these simple ones, you don't have to go through these steps. It's good practice for the more complicated problems so you know what to do, but we can see right away the answers to this. But we'll just go ahead and solve it. So we get x equals +7. So let's use the roster form. And when we do it in this fashion, we want to put it in ascending order. So we want to put the smallest answers first and then the largest. So in this case, it's -1, 7. We don't want to put 7, -1. 7's bigger, so we want it to the right. And that would be our solution. All right, so we have a story problem for this. So it says the volume of a sandbox shaped like a rectangular prism, which is just a fancy math term for a box, is 48 feet squared. It should be cubed. That should be cubed. Cubed, because it's volume. The height of the sandbox is 2 feet. The width is W feet, and the length is W plus 2 feet. Use the formula volume, or V, equals length times width times height to find the value of W. So we've read it. Now let's illustrate it. This is a rectangular prism. So it's a box. I'm not very good at drawing three-dimensional things. We have a box there. Comes out like this. We can do something like that, and those sections are behind. We can label it. We know that the volume is 48 feet cubed. And it gave us the height. So we'll say this is the height of 2 feet. It has the width is W, so we can say that's the width. And the length is W plus 2 feet. So we'll call this section going into the board W plus 2. So we need to find the value of W. What they've done is they've given us the formula for the volume. The volume will be the length. So we have the length times the width times the height. And they also said what it equals. So we could say 2 times W times W plus 2 is 48 feet cubed. And the units will cancel out, but 48 feet cubed. So this volume equals that volume. And we can go about solving for W. Now, what we want to do is to see if we can reduce our problem and make it easier to work with. So in this example, this 2, I can divide both sides by 2 and reduce it. So if I divide this side by 2, because that'll undo the multiplication, I'll divide that, and we end up with a simpler problem. We have W times W plus 2 equals 48 divided by 2 is 24. Now, we can't use the zero product property just yet because it doesn't make sense with how our problem's set up. So what we want to do is we want to expand this and multiply it out. So we'll distribute that W. We get W squared plus 2W equals 24. Now that we have these W's out, we can subtract the 24 because when we do that, we'll get 0 on this side. So let's go ahead and subtract 24 from both sides. We get W squared plus 2W minus 24 equals 0. So now we're getting something that we can work with. We'll look at this and factor. So let's set up our problem down here, and then I'm going to move it over here to have more space. So we have negative 24 adds up to positive 2. So we want factors of negative 24 that add up to a positive 2. We have 1 times 24, 2 and 12, 3 and 8, 4 and 6. And then it starts repeating itself. So one of these factors will be negative. So one of them will be negative. So we want to kind of get an idea of which one's going to be close to 2. If I subtract any of these, it's not close to 2. That could be 10 or negative 10. This is 5 or negative 5. This is 10 or, sorry, this is 2 or negative 2. We make this one positive and this one negative. That will switch the sides. If we make this one positive, that one negative, that adds up to a positive 2. So we have negative 4 and a positive 6 as our factors. So I'm going to go ahead and factor that out over here. We now have W minus 4 times W plus 6 equals 0. Using the zero product property, W minus 4 equals 0, and we'll solve for W. W equals 4. And then on the side, we have W plus 6 equals 0. Subtract 6 from both sides. W equals negative 6. So this is an application problem, so we always need to make sure our answer makes sense. Now, if this was just a math problem where no application, then we are done here. W equals 4 and W equals -6 feet, and that would make sense. But it doesn't in this case. So because W represents the width in feet, up here in our problem, it's the width in feet. Well, I have a width of 4 feet. Okay, that makes sense. Now this is a width of -6 feet. Well, that doesn't make sense in the context of volume. So we have to exclude that answer. So the only one left is the width is 4 feet. And we don't want to forget the units of feet. That's just as important as the number part. So in this case, the value of W is 4 feet. All right, so this is graphing parabolas or quadratics. It's kind of a lot of information here, but this is the notes section. So go back to this, write it down, take a picture, whatever. We want to reference this part. This will be helpful when you're solving some of these next problems. So when we're graphing parabolas, there's not really a particular order, but this is a good order to kind of work in. So we first want to look for the axis of symmetry. And the axis of symmetry is the line about which a figure is symmetrical. Really, what it means is for parabolas, there comes a point in the graph where it's a nice mirrored image. If I fold it right down the middle in half, then it's going to line up perfectly. So I'm interested in this right here, that x value that gives me that nice middle point. We can find that by plugging in -b/2a. So if I have a parabola that's x squared plus 3x plus 2, then the way I would apply this is -b refers to this term right here. So -3 over 2 times a. And a refers to the coefficient in front of here. So that's just 1. So that's just 2 times 1, or 2. So the axis of symmetry is x equals -3 over 2 for this particular problem. So what that looks like graphically is -3 over 2 is -1. So this is -half, -1, -3 over 2 right here. And it does this because our parabola will open like that. Okay, so that's just an explanation for axis of symmetry. Now we go on to the next one. The vertex is the point at which a parabola changes direction. When this parabola changes direction, that's the vertex. It also happens to be on the axis of symmetry. So the x portion that for the vertex is this axis of symmetry. We just need to do one extra step to find the y value, because we need the x and y value. So that's what this is right here. -b/2a finds us this part. Then we just plug in -3 over 2 into our expression up here, and out comes some y value. So we're not going to do that work right now, but we will in the examples. So just to make sense of this information, this is the x portion of the vertex. It's -b/2a. And then we plug that number into the expression, and out comes the y portion. So that's all this is. We have the zeros of the function, if it's applicable. And what that means, it's the point where the graph touches or intersects the y-axis. So that means if I have a graph that looks like this, this is the x-axis, that's the y-axis. It intersects here and there. Those are zeros. So the zeros of the function was where they intersect this right here. And it doesn't always intersect. So in that case, it intersects twice. In this made-up example, we have this, and it intersects it just once. It actually doesn't intersect it. It just touches it and turns around. And in this case, it doesn't touch it at all, or if the parabola does that or something. You can go down too, but it doesn't cross over it. So those are some of the examples. And for 5, determine it, or sorry, for number 4, determine if the graph opens up or down. So this is some additional information. We want to know which way the graph is going, if it's going up or if it's going down. So if it opens up if the leading coefficient is positive. So the leading coefficient is if we had 3x squared minus 2x plus 9. I'm just making this up. The leading coefficient is the coefficient of the leading term. So the leading term is all the way in front, and the coefficient is the 3. So that's positive. So that means because it's positive, it opens up, and the graph will look, I don't know, something like this, but it's pointing up. Now it'll point down if the leading coefficient is negative. So if that leading coefficient was negative, then it goes down, and it could look something like that. It just points down. And then finally, we can just plot a few points to get a general shape of the graph. We use this XY chart, and we just pick some points. So you might pick like, I usually will start with the axis of symmetry. So if, in this case, if it was 0, then I'll pick a few points on either side because it'll be a nice mirror image. All right, so let's move on to some problems with that. So in this case, graph each function, label the axis of symmetry and the vertex. So I have my graph here. We want to label the axis of symmetry and the vertex. Okay. So remember, the axis of symmetry is the kind of like the middle portion. And we can use, we'll go up here, negative b over 2a to find that x part. So we go ahead and look at this. Well, there is no b term. This is just 1/2 x squared and nothing else. So there's no b term. It's like plus 0 bx plus 0c. Well, we don't need those. So b is 0. So if we go negative 0 over 2a, I mean, it doesn't really matter. 2 times 1/2. Well, that's just 0 over 1 or 0. So that means the axis of symmetry is when x equals 0. So this is the axis of symmetry, which just happens to be the y-axis in this problem. Now, we want to find the vertex. Well, the vertex is the axis of symmetry, and when we plug in 0. So we can plug in 0. We have y equals 1/2 of 0 squared. Well, 1/2 times 0 is just 0. So in this case, the vertex is at 0, 0. Right here at the origin. Now, we don't really have to do anything else for this particular problem other than pick some points. So we'll go ahead and make an XY chart. Let's use the axis of symmetry as our midpoint. And I'll choose these points. Because they're the same distance from 0, they're going to have the same value. Also, I want to look at the sign in front of this leading coefficient. It's positive. So I know my graph is going to be moving in the upward direction. So let's go ahead and pick some points. We already know what happens when we plug in 0. We get 0. Let's see what happens when we plug in 1, because that's easier to calculate. Y equals 1/2 times 1 squared. 1 squared is just 1. And we get 1/2 times 1 is 1/2. I'll erase that. Give a space. We'll plug in 2 before. Since this is 1/2, that one will also be 1/2 with parabolas. So we'll go ahead and do for positive 2. Y equals 1/2 times 2 squared. So it's 1/2 times 2 squared is 4. And 1/2 of 4 is 2. So we get 2 here, 2 there, and now we can go about plotting this. So we have our origin. We already plotted that, 0, 0. We have 1 and 1/2. So 1 in the x direction, 1/2 in the y. And it's the same thing over here. They move, it's a mirror image. And then we have 2, 2, 1, 2, 1, 2, like this. 1, 2, up 2, like that. And it continues a pattern, but we have the general idea, kind of does that. All right, good. So we can go on to the next problem. For this one, we have y equals -2x squared minus 1. We want to label the axis of symmetry, so that's -b over 2a. There is no b term because the b term is the one with the x. Since there is no x in there, we have, this is ax squared. We have no bx, but we have c here. So again, that means b is 0. So 0 divided by something is just 0. So we will write, we know the axis of symmetry is 0. So that means x, when x is 0, we have this symmetry right here. Then we can go ahead and find the vertex. So we plug in 0 in our problem. So we have y equals -2 times 0 minus 1. So this is 0 because -2 times 0 is just 0. Then we have minus 1. So y equals -1. That means our vertex is 0, -1. 0, -1 right here. All right, so we have the axis of symmetry and the vertex. Now we just need to figure out which direction it opens, and then plot some points. So the leading term is negative over here. That means it's going to open in a downward direction. We can plot some points now. Pick the vertex for an easy point. And then we'll pick 1 and 2 in that direction and the same distance in the opposite direction. So we'll go ahead and start plugging these in. All right, so we'll do +1 because that looks easier. Y equals negative 2 times 1 squared minus 1. So simplify the exponent. This is 1 squared, which is just 1. Negative 2 times 1 equals, negative 2 times 1 minus 1. Negative 2 times 1 is negative 2 minus 1, and negative 3. So when we plug in 1, we get negative 3. Now erase that for some space. We'll plug in 2. Y equals negative 2 times 2 squared minus 1. Let's simplify. 2 squared is 4. Negative 2 times 4 minus 1. Negative 2 times 4 is negative 8 minus 1. And negative 8 minus 1 is negative 9. We get negative 9. That means we're going to have negative 3 here and negative 9 there. So we can go ahead and start plotting these points. And we already have the origin. We can do 1, negative 3, 1, down 3, 1, 2, 3, and 2, negative 9. We have 1, 2, down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. It'll be way down here. And we can do the same thing because it's a mirror image on this side. So over 1, down 3, over 2, down 9. So our graph looks like this. We have the vertex and the axis of symmetry. And same thing for this problem. Let's find the axis of symmetry first. That's negative b over 2a. So we finally have a b term in here. Negative 2 over 2 times a. And it's just a 1 here, so that's just 2 times 1, or just 2. That simplifies to negative 1. So the axis of symmetry is when x equals negative 1, which is right here. That's going to be the foldable section where it'll be a nice mirror image. Now we want to find the vertex. So the vertex is negative 1. And then I plug in negative 1 for x to see what the y value is. So we can go ahead and do that. We can say negative 1 squared plus 2 times negative 1 plus 4. Simplify this. Negative 1 squared is just 1. 2 times negative 1 is negative 2. So this is plus negative 2, or we can just say minus 2. We have plus 4. 1 minus 2 is negative 1. Plus 4 is a positive 3. We get a positive 3 here. That means our vertex is negative 1, positive 3. Negative 1, positive 3. I'll go ahead and erase this. So now we want to find which way it opens. This coefficient in front, the leading coefficient, is positive. So we know it opens up. Now we want to do an XY chart to plot a few points. So we'll start with the vertex, the middle section. So we have negative 1, 3, and I'll pick negative 2, negative 3, 0, 1. So I'm just picking 2 points on either side of the vertex. So we'll go ahead and it'll be easier to solve these two. So let's plug in 0. We have y equals 0 squared plus 2 times 0 plus 4. Simplify. 0 squared is 0, plus 2 times 0 is 0, plus 4. So we get y equals 4 when we plug in 0. I'll erase it. Next, let's plug in positive 1. So we have y equals 1 squared plus 2 times 1 plus 4. Simplify. 1 squared is 1. 2 times 1 is 2. And 4. So we can add this up together. We have 1 and 2 is 3. 3 plus 4 is 7. We get 7 here. These are mirror images. So this is just 1 away from the vertex. In the positive direction, this is 1 away in the negative direction. So we can go ahead and mirror that. And let's graph with our points. So first we have the vertex we've already put in there. And we have 0, 4. So 0, up 4, 1, 2, 3, 4. And then we have 1, 7. Actually, let's do the mirror side. So the mirror is negative 2, 4. Negative 2, up 4. Then we have negative 3, 7. So we have 1, 2, 3, negative 3, up 7. 1, 2, 3, 4, 5, 6, 7. Something like that. Then we have 1, 7. 1, 7. It goes up 7. Something like that. Then we just connect the dots. And our graph looks something like this. We have the vertex and the axis of symmetry. All right, we're getting close to the end here. So we want to solve each equation by graphing the related function. If the equation has no real number solution, write no solution. So we're given this equation, and we want to solve it by graphing the related function. So we know, or we want to know, what x squared is. So x squared looks like this. It starts at the origin, the vertex is at the origin, and it points up. Well, this right here is the graph of x squared moved down 16. So it's this same graph right here, but it's moved down all the way to negative 16. And it looks something like that. Now, if to find if this has a solution, a real number solution, what this is saying or asking is, does the graph intersect the x-axis or touch it? And this, we can see it does touch the x-axis, but we want to know where, because that's going to be the answer. If it doesn't touch the x-axis, so if it looked like this and never touched it, then that would be no solution because it doesn't touch the x-axis. So we can solve by graphing. So we'll try plugging in some numbers and see if we can get a number that equals, find a value of x that will make this 0. So we have x, y, so it's kind of like a process of elimination until you learn some additional tools. So we can try, we'll just try, since we know the vertex is right in the middle, we'll just do, start with 0, 1, 2, 3, 4, 1, 2, 3, 4. We'll just try it that and try each one. So 0, when I plug in here, it becomes 0 minus 16. Well, that doesn't equal 0, so I don't care about that. If I plug in 1, we get 1 minus 16 equals 0. Well, that doesn't work either. Sorry, these should be negatives. If I plug in 2, 2 squared is 4, so 4 minus 16 equals 0. Well, that's not true. If we do 3, so 3 squared is 9 minus 16. Well, 9 minus 16 is not 0, so don't care about that either. I'll plug in 4. So 4 squared is 16 minus 16 equals 0. Well, that's a true statement. So that means when x equals 4, and likewise, when x equals negative 4, it will equal 0. So these points are 4, negative 4. So we can, we could graph this and plot each point. We'd have to figure out the graph of x squared minus 16. It would be like, here's negative 16 down here. Then you'd have 1, it might grow a little more like this, a little more like that, and then all the way up here, it's at 4, 1, 2, 3, 4, and it kind of does something like this. But we would graph each point to find out where it intersects the x-axis. All right, for this one, we can take a look. This is the graph of x squared moved up 9 units. Now you may have learned this, you may have not. It's x squared and it moves up 9 units, so it just moves up. So now it's up 9 and goes like this. And we can see here it doesn't intersect the x-axis at all, but what we'll do is we'll see if we can notice any patterns in our xy chart. So we'll choose the vertex, or the axis of symmetry, which is just 0. And when I plug in 0, I get plus 9. So if I'm just interested in graphing this, we could say y equals x squared plus 9. So graphing this, when I plug in 0, this is 0 plus 9, or 9. Now if I do something like this, I want to find out what the next value is. Because I know this opens up, this is positive, it opens up. So that means my graph is going to, I have my vertex at 0, 9, we'll just say it's way up here. And I know this graph opens up because it's positive. So it's going to do something like this. Now, I could plot more points and try to do a process of elimination or some other method of deduction, but we already know that the vertex is way up here, and which direction it opens up, so it's never going to touch this x-axis. Since it'll never touch it, that means we have no solution, or no real number solution. Now, if we had this vertex in a similar problem, and we saw that, it was negative x squared, and it went down this way, well, I would know eventually it would cross over the x-axis, and I'd have to plug in more points to find out what that number was. But in this case, it's not. It's positive. We already figured it out. No solution. These are the last few problems for your study guide. This is solved by factoring. And my little hint is we're going to use the zero product property like we have been. So this is just back to some factoring. We have b squared plus 3b minus 4 equals 0. So for factoring, we want to set up our little factoring x. Factors of negative 4 go up top, that add up to a positive 3. So factors of negative 4, if I'm going to get a negative number, that means one has to be positive, one has to be negative. So factors of 4, we have 1, 4, 2, 2. 1 has to be positive, 1 has to be negative. We want them to add up to a positive 3. So if this was -1, positive 4, that adds up to 3. All right, so we have a positive 4 and a -1. So we'll set up our factors like so. We have b plus 4, b minus 1. Now we want to use a zero product property to solve for these variables. We'll set it equal to 0 because this part of the equation is 0. Subtract 4 from both sides, b equals -4. Now we'll do the same thing, b minus 1 equals 0, add 1, b equals a positive 1. So our two values of b that will make this equation 0 are -4 and 1. Two more examples. We have 2x squared minus 5x minus 3 equals 0. Now we can use the long method. We notice that there is a coefficient in front here, so we can use the long method. If you know another way, you can go ahead and do that. This is, we'll go ahead and multiply this out. So take that coefficient, multiply. So we end up getting x squared minus 5x minus 2 times -3 is -6. We want to factor this out. So we can do a little factoring x, -6 up top, -5 on the bottom. Factors of -6 that add up to -5. We have 1 times 6, 2 times 3. One of these factors has to be negative because we have a negative term up here, negative number. One of them has to be negative. So we have 1 and 6. If we add those together or subtract one from the other, we can do -1, positive 6. That doesn't work. So we can do a positive 1, -6, and that adds up to -5. 1 and -6. X minus plus 1, x minus 6. Now we take that number we multiplied and we put it in front of the x's again. 2 times x plus 1, 2 times x minus 6. We want to simplify or factor out any common terms here. This is 2x plus 1. We don't have any common terms, so we can leave it. 2x minus 6. They both have a 2 in common, so we can factor out a 2. And when we're done factoring out those little numbers, we want to see if this number matches that, and it does. So we are finished with that number, which just means our two factors are 2x plus 1, x minus 3. Now we can go about solving this. Using the zero product property, we have 2x plus 1 equals 0. Subtract 1. We have 2x equals -1. Undo this operation by dividing by 2. We have x equals -1/2. X equals -1/2. Now we can move on to this next factor. Add 3. X equals +3. So our two values of x that will make this equation 0, -1/2 and 3. And our last problem Congratulations if you've made it this far. We have 3n squared equals negative 6n. I can't really do anything here, so what I want to do is subtract 6n from both sides. So we get 3n squared minus 6n equals 0, because that will add up to 0. Now we want to look for any like terms or any greatest common factors. So if we look at just the number portion, they both have a factor of 3 in common, so we can factor out a 3. And they both have at least one n in common, so we can factor out an n. So what goes inside the parentheses? 3n squared divided by 3n. We just have an n left over. 6n, negative 6n divided by 3n. We just have 2 left over. That equals 0. So using the 0 property, product property, this 3n gets set equal to 0. Divide by 3. Divide by 3. N equals 0. 0 divided by 3 is 0. Then we have n minus 2 equals 0. Add 2 to both sides. We have n equals 2. So our two values of n are 0 and 2. So if you still need some extra help, go ahead and practice some factoring. Just more factoring. The more factoring you do, the better you're going to get. We have to do well in factoring because it doesn't go away. Hopefully you made it this far. And if you have any questions, just let me know in Discord.